Greetings, everyone. I'm Captain Pankaj Pahil. With 17 years of experience training pilots all across the globe, I am here to guide you through the absolute intricacies of the DGCA syllabus. Welcome to today's ground school session and explainer. We're taking a strictly authoritative, zero-nonsense approach today because what we're covering, well, it's absolutely critical.
There's a saying I want you to remember. The sky is not a canvas for pretty lights. It is a complex meteorological instrument panel. Meteorology isn't just some academic hurdle you clear to get your license. No, it is literally a discipline of life and death. Ignorance of these displays is a profound hazard. To fly safely, you must master the atmosphere. Okay, here's our flight plan for today's masterclass. We're going to cover 1. The physics framework. 2. Refraction, rainbows and halos. 3. Diffraction, coronas and rings. 4. Reflection and electrical hazards. And finally, 5. Our final approach exam checklist. Let's get right into it. Section 1. The physics framework. Understanding atmospheric optics.
So, understanding the root physical mechanisms is your foundational key to unlocking those tricky DGCA questions. We can break this whole subject down into 3 main pillars: concept, aviation application, and exam tips. The core concept here is that optical phenomena give us vital, highly visible clues about what the atmosphere is doing, things like cloud constitution and lapse rates. As for the application, well, you're going to use these visual cues right there in the cockpit for real-time risk assessment, specifically keeping an eye out for airframe ice accretion. And here is your DGCA exam tip. You absolutely must be able to categorize these events by their physical cause. Expect 2 to 3 questions testing exactly that. Right, so there are 5 main physics mechanisms generating these phenomena: refraction, diffraction, reflection, emission, and scattering. Getting a grip on this physics framework helps you instantly identify the particle type outside your window. For example, refraction usually means ice, while diffraction usually means water droplets. Your exam tip for this part: group them accurately. If an exam question asks about a phenomenon with rings, you immediately need to stop and determine if it's refraction, like a halo, or diffraction, like a corona. It's that simple, but you've got to know the difference.
Moving on to Section 2. Refraction, rainbows, halos, and mirages. The bending of light.
Refraction is essentially the bending of light through mediums like liquid water or solid ice. First up, we have the classic rainbow. The concept here involves double refraction and total internal reflection. A primary rainbow has 1 internal reflection and a 42-degree radius. A secondary rainbow, on the other hand, has 2 internal reflections, it's wider at 52 degrees, and it's much less bright. Operationally, a rainbow is telling you there's liquid water opposite the luminary. That's the sun or the moon. For the exam, I need you to lock in the mnemonic RAVEN bien. For a primary rainbow, it's red outside, violet inside. And remember, the secondary rainbow always reverses this. Now, let's consider the halo. This is a standard, safe operating cue. It's caused by refraction through ice crystals exclusively in cirrostratus clouds. The application here is a really crucial safety marker. If you're flying through a cloud and you see a halo, that's your green light. Ice crystals bounce right off the airframe, which means you have a negligible ice accretion risk. For the DGCA exam, you need to link the halo strictly to ice, cirrostratus clouds, and safe flying conditions. A great way to remember this is the mnemonic H for halo, H for high clouds, H for harmless. Still under the umbrella of refraction, we have atmospheric mirages. These are caused by light bending through air layers of entirely different densities. The concept breaks down into inferior and superior mirages. An inferior mirage happens with a steep lapse rate over a hot surface, like when you see fake water on a runway. A superior mirage happens with a temperature inversion over a cold surface, making objects, like ships for instance, appear to levitate. Your aviation application here is that this severely alters your visual perception on approach, requiring a heavy reliance on your instruments. The exam tip is very direct. Inferior equals lapse rate, superior equals inversion. Section 3. Diffraction, coronas, rings, and aerisation. Bending around edges. So, diffraction happens when light bends around the edges of small particles, like water drops. And this presents entirely different operational realities for us. Take the corona, for instance. This is an amber warning. The concept here is the diffraction of light passing through very small water drops in altostratus clouds or mist. The radius is extremely tight, less than 5 degrees. The aviation application here is a serious caution. A corona means supercooled water droplets are present, which translates directly to a moderate icing risk. Your DGCA exam tip, corona equals close rings, which equals supercooled water, which absolutely demands caution. The absolute crucial point here is knowing the difference. Confusing a corona for a halo while you're in the air, that can result in flying directly into severe icing conditions. On the exam, confusing them is just going to cost you marks. A halo is 22 or 46 degrees, ice crystals, and it's safe. A corona is less than 5 degrees, supercooled water, and it means caution. You need to burn this distinction into your memory. Now, here is a specialized diffraction case that poses a really severe hazard: Bishop's ring. The concept is the diffraction of light by fine dust up in the high atmosphere. Operationally, this is a severe warning. A Bishop's ring can be an early visual indicator of high-altitude volcanic ash, which, as we know, can stall jet engines. For the exam, please do not fall into the trap. Both Bishop's ring and the small halo have a 22-degree radius. But remember, the halo is ice and refraction. Bishop's ring is dust and diffraction. Totally different beasts.
Let's just briefly touch on 2 more key terms to make sure we're covering all our bases. Iridescence is a diffraction phenomenon where pink bands predominate, often seen in altocumulus lenticulus clouds. Twilight colors, on the other hand, are produced at sunrise and sunset by scattering and refraction. If you see these terms pop up on the exam, tie iridescence to diffraction and twilight colors to scattering.
Section 4. Reflection and electrical hazards, light bouncing, and energy emission. We're transitioning now from bending light to atmospheric energy emissions and reflections. First up, the operationally benign reflection phenomena. The glory consists of these beautifully colored rings seen around an aircraft's own shadow on a cloud below, and it's caused by reflection, specifically backscatter, from water droplets. Then we have crepuscular rays. These are just dark bluish streaks radiating from the sun, which are basically shadows of clouds below the horizon. They're beautiful to look at, but perfectly safe to fly through. For the exam, just remember, glory equals reflection around your own shadow. Now, let's move over to emission. The auroras are the excitation of gases between 70 to 100 kilometers in altitude by solar electric particles. The aviation application for this is actually quite significant. This high magnetic activity severely impairs high-frequency, or HF, radio communications, especially when you're flying over polar routes. The DGCA exam loves direct pairings for this one. Aurora australis means Australia, which means south. Aurora borealis means boreal forest, which means north. Okay, let's talk about severe atmospheric electricity. During a storm, local electrical charges reverse, which draws positive charges to the rain. We map 3 types of lightning to visually assess storm maturity. Ground discharge, which is a thunderbolt, hits the earth. Cloud discharge, or sheet lightning, stays entirely within the cloud. And air discharge goes from the cloud out into the air. The crucial exam tip here: air discharge lightning never, ever strikes the ground. Listen up, because this next phenomenon requires your absolute focus. It is a critical divert limitation, St. Elmo's fire. The concept is a bluish or greenish continuous luminous discharge right on the airframe, usually accompanied by a cracking sound. It's caused by extremely strong electrical fields. The aviation application here is a glaring red warning. It means you are dangerously close to or already inside cumulonimbus or cumulus clouds. Immediate diversion is required. For the exam, remember, St. Elmo's fire signifies strong electrical activity. Avoid CB and CU clouds entirely. Section 5. Final Approach Exam Checklist. Pre-exam memorization matrix. All right, we need to synthesize all this atmospheric data into a rapid recall format. Structured memorization is absolutely key here. You must memorize this exact sequence of angular values from smallest to largest to prevent any confusion on the exam. Less than 5 degrees, that's the corona. At 22 degrees, you have the small halo and Bishop's ring. At 42 degrees, the primary rainbow. 46 degrees is the large halo, and 52 degrees is the secondary rainbow. If you have these angles locked in, you can instantly eliminate the wrong options on those tricky multiple-choice questions. You also have to be able to cross-check these facts. Map the phenomenon directly to the mechanism, the cloud medium, and the icing risk. For instance, if an exam question states ice crystals, well, your answer simply cannot be diffraction or corona. Ice crystals go with refraction, cirrostratus clouds, the halo, and a negligible icing risk. Cross-referencing like this prevents unforced errors. As your ultimate pre-exam mental checklist, I want you to group these by hazard levels. Lock in the safe boundaries of the halo, the moderate icing caution of the corona, and the extreme danger of St. Elmo's fire. Plus, know the precise definitions for mirages and auroras. If you do this, you are absolutely guaranteed to see at least 5 questions pulled directly from this summary. I'm going to leave you with this high-stakes scenario. Imagine you're at the controls. You spot a luminous ring at a 22-degree radius in a zero-stratus cloud. Do you divert for icing or do you maintain course? Well, if you've been paying attention today, you know that's a halo, indicating ice crystals and harmless icing conditions. So you maintain course. Your understanding of meteorology is the difference between passing an exam and saving your aircraft. Master the atmosphere. Are you ready for the test? Good luck out there and fly safe.